Hello everyone, we are here with Professor Fahmi Himo from Stockholm University, a long-time friend. Actually, we've met, do you remember when we met? Actually, I don't really, many years ago. It was in Stockholm maybe?
Maybe either in Stockholm or in Perugia.
During one of your seminars, you were organizing quite very nice seminars about chemistry in
Stockholm. Yes, you visit us for conference and seminar.
And seminars, yes. So we know since long, but we never collaborated. So I know what the reason why you have been invited as visiting here within the project Vitality, but please tell us more about your expertise.
Well, as you well know, so we work a lot in modeling. So we use quantum chemistry, computational chemistry to model catalysis, in particular enzyme catalysis. So one of the things we are interested in is to valorization of maybe of biomass, how you can use enzymes to create building blocks for materials.
Fine. In fact, within Vitality, the idea of inviting you was within the spoke dealing with biomaterials and specifically how to give value to waste. So it was very a good opportunity for me, and I think also for the students of my group to have you here and speak about how we can progress in using enzymes and bio processes to give value to waste which comes from biomass.
Yeah, so computational chemistry can contribute in many different aspects. So one is the understanding. So you need to first understand what is going on in order to manipulate, and then but you can do many more things. So you can suggest rationally how to engineer enzymes to do specific tasks, selectivity, substrate scope, etc. So
this will be lovely because we are also looking for this within also Vitality. We are looking for very selective process, and basically we hope to collaborate in future just for this reason, just on this precise topic.
It sounds very exciting.
And what do you think? Because we are. My group and me, we are also very dedicated to sustainable processes, to definition of green processes. Do you think you can help us in your simulation and theoretical modeling of the biocatalysis?
Definitely. So computational chemistry has progressed a lot, and then you can study so many different things. So it's definitely doable.
Also to save the time for experimentation, maybe?
Yes, to save time and efforts. And you know, I always joke, I say the greenest chemistry is computational chemistry. You don't use any solvents.
At the end of the day, you have to do something. So we will hopefully do some bio-derived materials, which will be of interest.
Yeah, hopefully.
You are from University of Stockholm. Can you tell us a bit more about your institution?
The Department of Chemistry is in the Arrhenius laboratory, so we have expertise in many different fields. Right now I'm in the organic chemistry department, where there's catalysis and homogeneous catalysis, heterogeneous catalysis, but there's also in the bigger department there's material science, environmental chemistry. So many fields of chemistry are represented, and there facilities also to perform the research.
Arrhenius department, so it's a very big name for
Arrhenius laboratory.
Within chemistry. It's a name which reminds many things as a graduate student.
Yes.
But so, what do you think? You know, you are from a prestigious university with many important research areas. What do you consider the value of collaboration with other people internationally?
Oh, I think it's very crucial. Otherwise, you stay in the same. It widens your. And also, people come in with different expertise from different angles. This is one of the essential parts of today's research. Nobody can be alone.
Yes, and in fact, I would say even we don't have here people dedicated from computational approaches for catalytic processes made by enzymes. So you are very welcome, and your contribution, I'm sure, will be valuable.
Thank you very much. I look forward to collaborating.